name is Allison Dyevoich, and in Dr. Karen Haas's lab, we study how we can manipulate the immune system to target cancer. Specifically, I study peritoneal carcinomatosis, which is an obnoxiously long word that describes a condition where tumor cells simply find themselves in the peritoneal region. So all of your abdominal organs are contained in a sac-like component called the peritoneal cavity, and when tumors find themselves in the peritoneal cavity, not only do they grow more, but they also recruit liquid fluid into the peritoneal cavity known as ascites. So ascites is actually the main factor that causes death in these patients, and it takes about 20 weeks post-diagnosis that's anticipated for their survival. So this is a very poor survival, and most of the treatments that are currently available for this disease involve draining the ascites from the peritoneal cavity, as seen in the upper left-hand corner. But unfortunately, this doesn't take into account the tumor cells, and patients still die from this disease, and it is only palliative treatments that are currently available. So that being said, our lab looks at if we can use the immune system to target these tumor cells in the peritoneal cavity as a way of treating this disease. So what we do is we take an immune stimulant and we try and activate the immune system in a mouse model in order to treat them. So mice that are just given tumor cells have about a 20% survival, which is indicated on the lower left-hand corner. However, when we give this immune stimulant, these mice then have a 100% survival. 100% survival. And that's a very stark finding, and we decided to look at what immune cells are being activated in order to induce this response. So the peritoneal cavity actually has a very specific cell type in the cavity called B cells. I don't know if you've heard of them. They make antibody. And what we found that if you do the same experiment in a mouse that lacks B cells, called the MUMT mouse, as depicted on the bottom right-hand corner, when you give the same immune stimulant, they are no longer protected from these tumors. So this would indicate that these B cells play a critical role in inducing this anti-tumor response that we see when we activate the immune system. So that leads to my project. My project focuses on determining what exactly these B cells are doing in order to induce this anti-tumor response. So B cells can do a number of things. They can secrete antibody, but they can also make other chemicals that promote anti-tumor responses. They can also activate other cell types that can kill tumor cells, and they can also directly kill tumor cells. So hopefully I'll be able to determine the exact mechanism in which these B cells are inducing this response, and then we can translate it into a treatment that is not palliative but curative. Thank you.